Okay, in the previous video, which is part 3, we looked at this complex function. We worked out some Laurent series for the region where mod z is between half and 2, and the region where mod z is greater than 2. This time we're going to go on and look at the Laurent series where mod z plus 2 is greater than 0 but less than 5 halves, and then the case where mod z plus 2 is greater than 5 halves. We've already mentioned that this tells us straight away that the series is going to be centered at -2. Say if you set this thing equal to 0 and solve, then that tells you where it is going to be centered. We also showed that this function can be written in terms of partial fractions as shown here. So the singularities, so there's going to be one at 1/2, and then there's going to be another one at -2. So 1/2 here, and -2 here. The region of interest is centered at -2. So what we want there is the region which is just excluding -2, and then it's going to go all the way to that point 1/2. The distance then is 5 halves. So the radius of this is 5/2. So that is the first region here. So if you like, we want the region inside this circle here, but outside this very small circle there. Okay, so the way we're going to go about this is we're going to introduce a transformation. So we are going to let u be z plus 2. So the other thing that we mentioned is that if the region is stated like this, it means the series is going to be in powers of z plus 2. Same thing here. So we're going to let u be z plus 2. This implies that z is u minus 2. Then if we express this in terms of u, it's going to look a bit like this. So this is going to be 1/2 into u minus 2 minus 1. And the second one is going to be u minus 2 plus 2. So, well, the second one is just going to be 2/u, which is already in powers of u, because that's 2u to the power -1. And then this other one is going to be 2u minus 5. So this is the one that is going to be associated with the singularity here, which is a distance of 5 halves. Now, since we're looking for the region inside this circle here, then we're going to factor out the constant. So the first thing we're going to do here is write this as 2/u minus 1/5 minus 2, because we want the constant to be positive. And then after that, we're going to factor out the 5 in the denominator. So we're now going to have 1 minus 2u over 5. And then by the result of the geometric series, this is going to be the summation of 2u over 5 to the power n, and goes from 0 to infinity. This we can simplify, well, just rewrite as 2u to the power n all over 5 to the power n plus 1. And then after that we can express this in terms of z. So remember, u is z plus 2, so that's just going to be 2 over z plus 2, which is basically same thing that we started with. And then this one is going to be minus summation of 2 times z plus 2 all to the power n divided by 5 to the power n plus 1. So that is going to be our series in that region. Just to make sure that this is indeed in the right region, we're going to use the conditions of convergence from the angle of the geometric series, because if we write this in this form, then this is going to be convergent whenever magnitude of this is less than 1. So we're going to 2u over 5 is less than 1. So this is going to be, say, magnitude of u is less than 5 over 2. And then, of course, u is z plus 2. So this is saying magnitude of 2 is less than 5 over 2, which is indeed the region inside this circle here. And then, of course, this one here is going to be valid whenever the magnitude of this is greater than 0. So the other one is magnitude of u is greater than 0. U is z plus 2. So whenever magnitude of 2 is greater than 0, then these two we can combine, of course, and we get this compound compound inequality which describe that region. Okay, so then in the second part of the question, which is part D, we're looking for the series that is going to be valid in the region outside this bigger circle here. So again, we said if we're looking for a region outside a particular circle, we factor out the variable. So this time we're going to start from here, and then with this fraction here we're going to factor out the variable. So this is how it's going to go. So in D we have got f equal to 2 over u plus 1 over 2u minus 5. So this time we are going to factor out 2u in the denominator. So this is going to be 1 minus 5 over 2u. So this is going to be 2 over u, 1 over 2u, summation of 5 over 2u to the power n. And then this we can simplify as if we multiply this term into the summation. So this thing is going to be 5 to the power n 2u to the power n plus 1, n from 0 to infinity. And then again this in terms of z, 2 over z plus 2 plus the summation of 5 to the power n 2 into z plus 2 raised to the power n plus 1, n from 0 to infinity. So remember again, this first term here is going to be good enough whenever z plus 2 is greater than 0, as demonstrated earlier. This second one is going to be good whenever magnitude of that is less than 1. So 5 over 2u magnitude of that is less than 1. This tells us that okay, or if we just flip it, so this is saying magnitude of 2u over 5 is greater than 1, which in turn is saying 2/5 magnitude of u is less than 1. So this is saying magnitude of u is greater than 5/2. And then of course u is z plus 2, so that's what that is saying. Now the intersection of this and this is just going to be this one here. So that is going to be the region where the series is convergent, and hence the region that we require. All right, so at this point we are going to give you an opportunity with this function here that we met in part 3. So this time we would like you to have a go at part C and D. So find the Laurent series of this function valid in this region and this region. Just want pause the video, work through it, and then when you continue the video you can compare with our solution. Okay, we're now going to scroll down to our solution for the Laurent series of this function and these two regions here. We'd like to take the opportunity to thank you for coming to our channel and watching this video. We hope that it is useful to you. We do ask you to subscribe, of course, to our channel to support us so that we can make more videos like this one. If you have got any questions or comments, please do post them on the comment section below. All right, so this function here, we have shown in part 3 that it can be resolved into partial fractions as shown here. So from here we see that there's a singularity at 1. From this one we see that there's a singularity at -4. So in the first instance we're looking for a Laurent series that's going to be convergent in this region, which is inside the circle here of radius 5, but excluding the singular point at the center. So this is centered at a singular point 1, and it's got a radius of 5. So the thing we're going to do is let u be z minus 1, so z is u plus 1. Then f takes this form here, in which case this one is already in terms of powers of u. Since we're looking for the region inside the circle, here we're going to factor out the constant, and then the series ends up looking like this. Then in terms of the convergence, this one is going to be convergent so long as the magnitude of this is bigger than 1. And then this one is going to be convergent so long as the magnitude of that is less than 1. So here we have got, so magnitude of -1 is just 1. So it's just going to be 1 over 5 magnitude of u if you take it to the other side. So magnitude of u is greater than 5. That is an error there. That should be less than 5. Okay, so and less than 5 there, and then if you combine these two, we get this region here, which is the required region. Then in question D, we're looking for a Laurent series that's going to be convergent outside this circle here. So Laurent series is going to be convergent outside. So we're just going to go to our f in terms of partial fractions. In the second fraction now, we're going to factor out u. So we say generally if you're looking for the region outside a particular circle, so for that fraction related to that singularity, you factor out u. If you do that here, this is what we're going to get, and that is the final expression there. So this one is still the same as before because it corresponds to this fraction. But for this one, we now have mod of -5 over u is less than 1. If we flip this over, the inequality is reversed, and then this is just going to be mod u over 5, and then we take 5 to the other side. So that's going to give us that. And then the intersection of these two is this one, which is what we have there. Okay, thank you very much.